Welcome to another tutorial. In this particular video, I'm going to have part one of differentiation. Yeah, so I need to write this clearly so that you can be able to see differentiation techniques that you're going to be involved. So we're going to look at questions of different differentiations that you may be able to meet in your course. So this equation here, in order to differentiate this, and something that you need to remember that we are having y equals to x raised to power n, then dy dx is going to be equal to nx n minus 1. So that is exactly what you're going to get. And the moment you differentiate a constant, your answer is going to be 0. So here I'm going to rewrite this equation so that I have y is equal to 2x power 5 minus this can be written as x raised to power negative 1 over 2 plus 3x, so that I remove this square root from down here. So what I'm going to do, I'm going to say dy dx in this case is going to be, this is basically 5. I'll take it down so that it becomes 10 x raised to power 4. I'll take this negative half down to becomes positive, so I'll have this x negative 1 over 2 minus 1, that will be negative 3 over 2. Then differentiating 3x, I'm going to get 3 like that. So basically that's what you do when it comes to differentiation. Then this one here, I'm going to rewrite it first, and this is going to be 2 over 3x minus 4 raised to power 1 over 2. And I can rearrange it further, and it will become 2, rather I'll take it up into 3x minus 4 raised to negative 1 over 2. So with this one, we can be able to perform the differentiation. And to differentiate this, we're going to use chain rule. So this is going to be dy dx. In this case, I'll take the power down without looking at what is inside here. So I'll take the power down and decrease it by 2. So I decrease it by 1. So this is going to be negative a half times 2 will become negative 1 into 3x minus 4 raised to power negative 1 minus 1 becomes negative 3 over 2. Then I'm going to multiply it with differentiating what is inside here. I'm going to get 3, then I'm going to multiply by 3 there. So meaning I treated this as a single term. I applied the power rule. Then now, once I'm done with that, I'm going to differentiate the inner function and then multiply it there. So that we're going to have negative 3 into 3x minus 4 raised to power negative 3 over 2, like that. So we can be able to leave our answer that way. By any chance, you can be able to write this answer like negative 3 over 3x minus 4 raised to power 3, then now square root. You can be able even to write it that way. On this one also, is just the same approach we applied here. We're going to say dy dx is going to be equals to, we are going to assume anything that is inside the bracket, and we're going to say this is going to be 1 over 4 x minus 5 raised to power 2 minus 1, and then I drop my 2 here, and then I'll multiply whatever I get if I differentiate the function that is inside the bracket, and that is going to be 1 over 4. And this is 1 over 4 times 2 is going to be 1 over 2 here into 1 over 4 x minus 2 raised to power 1. Basically 1 over 2 into 1 over 4 x minus 2. We can leave our answer that way. This one we're going to use product rule. We are going to use product rule, whereby we're going to say this is two functions. So we can say the first function is f of x, which is equal to, we can say the first function here is u is equals to x cubed, and the second function is v, which is 4x squared minus 3. So du, differentiating this, just use so I can call this first function f of x equals to x cubed. I can call this second function g of x equals to g of x equals to 4x squared minus 3. Now, I can be able to differentiate this and also differentiate this so that I can be able to apply product rule. So this f prime of x is going to be equals to 3x squared. G prime of x is going to be equals to, differentiating this to be 8x. Now, whenever you're applying product rule, you are going to use dy dx is going to be equals to what? Is going to be equals to f prime of x gx plus g prime of x f of x. So you differentiate one, you keep the other one constant, plus you differentiate the one that you left constant, and then you keep the first one constant. So this one is going to be f prime is going to be 3x squared. Then the function g of x is going to be 4x squared minus 3. Then plus. Now g prime is 8x into bracket g prime of x is that f of x, which was x power 3. And then this is going to be equals to this is going to be equals to, you can multiply here, we are going to get 12x power 4. This will be minus 9x squared. This time this is going to be plus 8x power 4, right? So this is going to translate to 24x power 4 minus 9x squared as the answer to that. This question here, we're going to use quotient rule, and the quotient rule is where you have d of dx, u over v. This is going to be v du dx minus u dv dx over v squared. So you can identify your u and your v. So our u is actually 3x power 5, and our v is going to be equals to 1 minus 3x. So du dx is going to be 15x power 4. dv dx is going to be, differentiating v, we're going to get negative 3. Okay, which means that our dy dx in this case is going to be v. Our v was this, so we are going to say v is 1 minus 3x times du dx. Du dx is this, which is 15x power 4 minus u. Our u is this, 3x power 5 into bracket dv dx, and dv dx here is minus 3. Then divide by v squared, and our v was 1 minus 3x, and then squared, like that. We can be able to simplify this further. Of course, we can be able to simplify, and this can be what? I can just write it as 15x power 4 into 1 minus 3x minus, now it will be plus, because minus will become 9x power 5 divide by 1 minus 3x raised to power 2. So that is what I can simplify it up to. I can now leave it at that point. So the next question is this: how do you differentiate exponent? Exponent, when you find the y dx of an exponent, you are going to differentiate the power here. You multiply it in front here. So this is going to be 6x. This, differentiating this top, it will be 6x times 4, it will be 24x. Is you write the way it is, like that. You are done. This one, you are going to say dy dx, differentiation of a trigonometric function. You are going to differentiate this inner function you have here. You multiply it by the number that is outside the sign. If there is no number, you multiply by 1. So meaning this is going to be 15 cos 3x. Meaning you differentiate this one, you multiply it outside here, then you differentiate sign. Differentiating sign, you get cos, but you keep what was originally there. And this one, we are going to differentiate what is inside here first. Differentiate this times outside here. So it's going to be equals to differentiating 1 over 14, differentiating 1 over 4x, you're going to get a quarter. Yeah, a quarter times 8 is going to be 2, and this will be, and differentiating cos, you are going to get negative sine 1 over 4x, and the final answer becomes negative 2 sine 1 over 4x. So basically, those are some of the differentiations that you are going to perform. And maybe to bring to your attention, if you are given a trigonometric function that has got maybe if you are given a question like this, let me add question number 9. If you are given y is equals to cos 4x minus 3 raised to power 8, how can you differentiate this? So the first thing that you are going to do, so dy dx, yeah, is going to be, look at the power, don't look at what is inside here. Differentiate normally using power rule. This is going to be 8 cos 7 4 x minus 3, the first thing you have to do. And then now, don't look at the power, differentiate the cosine, it will be minus sine 4x minus 3. Then once you have done that, differentiate what is inside here, also multiply to this, differentiating what's inside now here is going to be 4. So finally, our answer becomes 4 times negative 1 times 8, it becomes negative 32 sine 4x minus 3 cos 7 4x minus 3. And that is the final answer in that case. So whenever you are given powers of trigonometric functions, you are going to do it like that. So you want another one? So that we have the first 10 questions. If you are having y is equals to 3 sine 1 over 8x raised to power 4. So first we say dy dx. To differentiate this, we are going to treat this as a power. Don't look at anything that is here. So we are going to take the power down. It will be 3 times 4 sine power 3, because the power decreases by 1, 1 over 4, 1 over 8 rather, x times. Don't now treat this power. We have already done with it. We look at the sine function. It becomes cosine, it becomes cos 1 over 8 x. Once we have differentiated the cosine, now let's look at this function inside here. If you differentiate it, you are going to get 1 over 8. So 1 over 8 times 4 times 1 times 3. This is going to be equals to 1 over 8 times 3. Write properly. 1 over, let me write properly. 3 times 4 times 1 over 8 sine power 3, 1 over 8x cos 1 over 8x. Simplifying here, we are going to get 3 over 2 sine power 3, 1 over 8x cos 1 over 8x. So basically, those are the differentiation methods and techniques you'll be using. And if you have found value from this particular video, consider subscribing so that anytime I'm going to upload the next video. See you in the next video.